Well, I'm using some extraction tape to pre-install the ESC, so I will tape the ESC in each positions in order to install the upper plate correctly, so it will be more easy during this process. So I will use 4 small band of tape to pre-install the each ESC. Well, after tape it, I use some strap, plastic strap to mount more solidly the ESC on both around 4 sides, and use some heat shrink together, the red wire with the black one. I will use 2 other black and red wires in order to install first a direct connection to an OSD, okay, to measure the 3S battery, and another derivation of the cable to use a first step down voltage regulator from 11 volts to 5, okay, and after I will use a second stage of step down voltage regulator to go down 3.8 volts, because my VTX in camera works at such voltage. It's only a 200 milliwatts VTX. Okay, I finished the soldering session, so as you can see everything is installed. So I make the 2 big soldering job, gathering all black, all ground wires. So ending with the TD connectors, as you can see I install a first step down regulator, so it will provide me around 5 volts. So well, as you can see there is a problem with the color, because I bought this GST connector in Banggood, and well, at this time the color was inverted, so be aware if you buy such kind of GST connector. So we'll after use this second stage of voltage regulator in order to deliver a clean interference-less 3.8 volt, which is a nominal voltage I found working very efficiently. For example, the 200 milliwatts VTX takes 58000. So well, so also use this output for the OSD, which is nothing else than the battery voltage. So it will be plugged into the BAT1 of the OSD. Okay, I installed the first motors, for example, for the clockwise sense. So be aware that in these cases the motor is ending with the air, so it means that you have to screw the prop locks in counterclockwise. So well, I was afraid that the provided wires from the motors was too short, so I solder some 5 centimeters of extra wire in order to correctly and easily connect to the ESC. Okay, so I will do the 3 other motors like this before to solder to the each ESC. Hi, here is a 2 cents tips when you are building a quadcopter. If you are buying such kind of Emax ESC as for example this 12 ampere, well, like this, and well, in order to, for example, to build a small 250 size, so you can buy, for example, the ZMR 1804 motors. So be aware that you have 2 types. You have the clockwise and counterclockwise. So for example, the clockwise are ending with the R at the end, because the prop slots here, the prop clocks, have to be screwed in counterclockwise. Okay, so and how to manage to associate with the UAC. Usually if you flat your 3 wire on your motors, and the same for the UAC with the laters face front of you, looking on the sailing. You just have to connect the left wire with the left wire, the central one to the central one, and the right one to the right one. In this scenario, you obtain a clockwise motor. So in these cases, be sure that your motors there is ending with the R, because you need that your lock props should be screwed counterclockwise. So in another hand, if you want to build counterclockwise motors, so you should take one motors without an air at the end, and after you need to swap 2 wire over 3. For example, you take the flat version and you swap 2 wire like this, and in these cases you are sure to obtain a counterclockwise. Okay, thank you. Okay, I just finished to install all the motor and the wire. So I first checked motor by motors is the sense of rotations. I will show another video how to proceed thanks to this great CGS software. But at the end it's installed. I've got 2 output there. One is for the OSD direct plug to the 3S voltage, and this one is the first output of the first voltage regulator. So I step down close to 7.4 volts, and after I will use this second stage of voltage regulator. This is a Pololu, and we'll go down to 3.8, 3.9 volts, because we'll use simple camera of 170 degrees field of view, very basic camera but working well, and a simple 200 milliwatts of ATX. So while I can only power these laters to 3-4 volts, eliminating all interferences and and lowering the consumptions in order to avoiding to warm a lot. So okay, I will show how to configure step by step and indirectly how to show how easy it is to configure the CC3D boards thanks to this great software, and during your motor installations to to calibrate UAC one by one and to check that the motor is rotating in the right sense. Okay, welcome to this step 2, the configuration of the CC3D boards, with the complete setup. So I plugged the 4 motors, so the sense of rotation of numerization, nomenclature of notation is very simple, clockwise sense, so M1, M2, M3 and M4. So from top to bottom you have M1, M2, M3, M4. So this step is thanks to via the CGS software, will help you to check if you correctly connecting your motors, if they are correctly spinning clockwise, counterclockwise, clockwise and counterclockwise. So the first step, I will power the OLESC, bind with my demo, and open the CGS software. So first I will connect the ASC. Okay, I will turn on my demo. Okay, then plug the USB like this and use the OpenPilot CGS software. Okay, so when you are in this step, you have to check first that it's well binding. You have a green light there, and so you have to press this green button there. So that they say that you have to absolutely to remove any props. Okay, so no props installed, so it's very important for safety. You clicking next. They ask to upgrade the firmware, but since I'm up to date, so I'm clicking directly next. And well, the open pilots try to see where is the connection with the card, so everything is okay, so I'm clicking next. And since I'm using my FarSky receiver in CPPM mode, as you can see, only the channel 1 is connected, and I installed the jumper between the signal pines of channel 3 and 4. Okay, I will click on PPM here and clicking next there. So it's for a quadcopter, so multi-rotors, and it will be a quad NX configuration. And since I don't know, I'm clicking next for the type of ESC. So to resume, have all this prior, and I will clicking next now. So I will compute, launch the ESC configuration, calibration there. So first you have to press this button to calculate. So they ask, when you are doing this step, your quadcopter should be on the flat surfaces. So okay, it's the case, and on the table, so it's briefly gyroscope calibration. Now the next step is to calibrate each output, each ESC. So they remind again to remove props. And I will start with the first motor, so on the top left should be clockwise. So you have to press start there and to move the slider until the motor starts to spin. As you can see, start to spin, and I will decrease the slider until it will stop. As you can see, it's turning clockwise. So now I will play a bit with the threshold. So, and okay, it's more or less okay. So I'm pressing stop and going to the next motors. So it will be the same operation, pressing start and check if it's turning counterclockwise. As you can see, it's turning counterclockwise, so it's okay. The wiring is okay. I try to find the threshold. Okay, seems to be okay. I'm pressing stop and clicking next. The third motor should be clockwise, so press start. As you can see, it's turning clockwise. So I will adjust now the should be okay. Maybe a little bit. Okay. And the last motors. So we start, press start, and should turn counterclockwise. As you can see, it's turning correctly counterclockwise. If you have a problem with the rotation of your motor, you just need to swap 2 wires over 3 of your motors. Okay, should be okay. Stopped. And now ESC are more or less calibrated, so I'm clicking next. I'm saving the data. Okay, it's saving to the board, I guess, and clicking next, and it will be the radio setup. So I already did it in a former video in the labs, but I can show again. So they say that all parameters, it's an arm quadcopter, so you have to, at the last stage, to reactivate the arming option. So say welcome to the radio wizard configuration. You click next there, and they ask you if it's a quadcopter or helicopter. So it's basically a quadcopter. So clicking next, and what time? Mode 2. Well, I will be in mode 2. So throttle on the left and pitch and around on the right. So now when you are coming that, you have to move, as indicated in the radio, the left stick. And when you're doing that, now you have to move the right stick, sorry. Then the right stick again, but up and down. And finally the left stick in for the U. Okay, when you are doing that, you have to play with your auxiliary button. So me, I configure my demo with a three position switch button there. So I'm clicking several times there. So now it's done. They ask us another auxiliary, 0, but for me it will be this button, this two-state switch button. And they ask another auxiliary, so I will use these spots there. And the last, it will be this spot. Okay, when it's done, they ask to center all the sticks and knobs. So I will do that and check center and press next. So now you have to move all the sticks in maximum direction. Okay, this is correct. And now this three-state position and the stick, this one, this switch to state 1, and the auxiliary up, maximum minimum values, and this one. Okay, so one is done. You verify that you're moving your left stick correctly. It's perfect, and the left stick also is perfectly working. Okay, so the green news that is already so immediately that you're using the CPPM, so it's working efficiently. Clicking next, and this step is to check that everything is working well. So in the right sense, so in these cases you have to inverse either in the CGS or in your radio model file. Okay, so there is a little bit some delay, but it's working. For example, if I'm turning the right stick on the right, okay, it's working well. The threshold, perfect, and the switch button. Okay, so when it's done, you're clicking next, and it's done. And after, you have to indicate, for example, how you want to arm your quadcopter. So if you want in the multi-way way, you click on your right there, and when it's done, you press on saved, and it's done. Okay, this is a excellent. I find this wizard. It's to configure a quadcopter very easy. So, well, the CC3D board is excellent and very easy for beginners. Okay, after calibration, I installed some props, some 50-30 3 blades. Okay, so Well, it's scaling close to 290 grams. Well, with this camera I've didn't yet fixed the FPV stuff, but I will use this camera, which is a 120-degree field of view. Well, I'm thinking how to install all the FPV stuff, where to place the VTX, Axon. So maybe I will install an OSD here, and there are lot of free room, so it will be better. So, well, definitively, so to mount the upper part, you have to ensemble them before. Okay, so I would advise to start with the main, the main plate there. So, and you can use a small caoutchouc hammer, you know, to make everything to fill all the gaps, etc. So start with this main one, this one, and after this tiny plate, which is used to fixed on the upper board, and of course don't forget your camera mount. So when you did that, you put this upper part and go down until reach this point. It can be done more or less easily, and after you have to use this screw. Okay, so basically design is nice, seems to be quite solid, and well, now I'm thinking to the FPV part.